Scientists find a new clue to life on Mars with a Martian meteorite found on Earth in 2011. A mineral trapped in a Martian meteorite that fell to Earth has revealed traces of water on Mars dating back 4.45 billion years, according to new research. The zircon grain may contain the oldest direct evidence of warm water on the red planet, which may have provided environments such as hot springs that are associated with life on Earth. The discovery opens up new ways to understand whether Mars was ever habitable in its distant past. It also adds further support to observations already collected by the fleet of spacecraft orbiting and touring the red planet, which have uncovered evidence of where rivers and lakes once existed on the Martian surface. But key questions remain about when exactly water first appeared on Mars and how it evolved and disappeared over time. Scientists analyzed a sample from the Black Beauty meteorite, also known as NWA 7034, which was found in the Sahara Desert in 2011. The meteorite was ejected from the Martian surface after another celestial object impacted the planet between 5 and 10 million years ago, and its fragments have served as a key source for studying ancient Mars for years. The new study, published in the journal Science Advances on November, the team's analysis shows that water was present only 100 million years after the planet formed, suggesting that Mars may have been capable of harboring life at some point in its history. Our data suggests the presence of water in the crust of Mars at a time comparable to the earliest evidence of water on Earth's surface, about 4.4 billion years ago, said the study's lead author Jack Gillespie, a researcher at the Faculty of Geosciences and Environment at the University of Lausanne in Switzerland, in a statement. The rocks may hold the answers to some of the most important remaining questions about Mars, such as how much water there was and whether life ever existed on the planet. Carl Agee, professor and director of the Meteorite Institute at the University of New Mexico, first introduced the space rock to the scientific community in 2013. It is the only source of pieces to the geologic puzzle of pre-Noetic Mars, but Black Beauty revealed some of its secrets. The space rock also contains the oldest known pieces from Mars, including the oldest zircons, Cavosi said. Zircon, used in products such as jewelry, ceramic tiles, and medical implants, is a tough mineral that can help scientists sift through the past and determine the conditions present when it crystallized, including the temperature at the time and whether the mineral interacted with water. Zircon contains trace amounts of uranium, an element that acts as a natural clock, said Gillespie, who was a postdoctoral research associate in Curtin University's School of Earth and Planetary Sciences at the time of the study. This element disintegrates into lead over time at a precisely known rate. By comparing the ratio of uranium to lead, we can calculate the age of crystal formation. Black Beauty's zircon remained undisturbed during its journey to Earth and its fiery entry into our planet's atmosphere before crashing into the Sahara because it was protected by its location inside the meteorite's interior, Cavosi said. During analysis of the zircon grain, the study team detected unusual amounts of iron, sodium, and aluminum, suggesting that water-rich fluids left these traces in the zircon when it formed 4.45 billion years ago. Such elements are not usually found in crystalline zircon, but the researchers' atomic-scale studies of zircon showed that the elements were incorporated into the crystal structure and lined up like fruit stands in a market, Cavosi said. We could tell from the patterns of how iron, aluminum, and sodium, are found within the zircon that they were incorporated into the grain as it grew, like layers in an onion, Cavosi explained. On Earth, zircons from hydrothermal systems which form when water is heated by subsurface volcanic activity, such as the upward flow of hot magma, have patterns similar to those found in Black Beauty. If hydrothermal systems existed in the Martian crust 4.45 billion years ago, it is likely that liquid water reached the surface.